Here we'll explain what hydrolysis means and introduce acid and base hydrolysis. Many words start with the prefix hydro. Hydro is derived from the Greek word for water, and it means pertaining specifically to water. In acid-base chemistry, hydrolysis means the reaction of an ion with water to produce either a hydronium ion or a hydroxide ion. It is important to remember that hydrolysis is always the reaction of a charged ion with water, not a neutral species with water. We can also speak about hydrolysis of a salt, which means the hydrolysis of one or both of the ions in a particular salt. There are two main types of hydrolysis: acid hydrolysis and base hydrolysis. Acid hydrolysis is the term we use for the reaction of an ion with water to produce a hydronium ion. We'll illustrate an example of acid hydrolysis. We'll start with an ammonium ion, NH4+, and a water molecule. These move randomly in solution and in some cases collide with each other. One of the hydrogen atoms on the ammonium ion will donate its shared electron to the nitrogen atom and become an H+ ion or proton. The overall positive charge on the ammonium ion we'll now consider as being the positive charge on this proton. The proton is now transferred to the water molecule, forming an ammonia molecule and a hydronium ion. The positive charge on the proton we consider as the overall charge on the hydronium ion. These two now move apart from each other. The equation for the acid hydrolysis of the ammonium ion then is NH4+ plus water gives NH3 plus H3O+. So in acid hydrolysis, an ion reacts with water by donating a proton to it, forming the conjugate base of the ion and a hydronium ion. Base hydrolysis is a term we use for the reaction of an ion with water to produce a hydroxide ion. We'll illustrate an example of base hydrolysis. We'll start with a water molecule and a fluoride ion, F-. In the random movement, these two species sometimes collide with each other. This hydrogen atom can donate one of its shared electrons to the oxygen atom, forming an H+ ion or proton, and giving oxygen a negative charge. This proton now leaves the water molecule and combines with the F-. The H+ and F- form a neutral molecule of HF. So we're left with a hydroxide ion and a molecule of HF, which then move apart from each other. The equation for the base hydrolysis of the fluoride ion, F- then, is F- plus water gives HF plus OH-. So in base hydrolysis, we have an ion which reacts with water and removes a proton from it, giving the conjugate acid of the ion and a hydroxide ion. To review, acid hydrolysis is the reaction of an ion with water to produce a hydronium ion. For example, the ion NH4+ acts like an acid with water, donating a proton to water to form its conjugate base, NH3, and a hydronium ion. And base hydrolysis is the reaction of an ion with water to produce a hydroxide ion. For example, the ion F- acts like a base with water, removing a proton from water to form its conjugate acid HF and a hydroxide ion.